In this follow-up video, what we're going to do is we're going to do the last example of linearizing graphs that we need. We'll see exponential decay in various places in physics, so we need to be able to figure out how to linearize graphs with exponentials. To do that, we'll use the logarithm laws. So you will have seen these before in maths. So what we're going to do is we're going to rearrange this function so as it looks like constant equals variable, wrong way around, variable equals constant times variable plus constant. Now, this is the charge decaying on a capacitor. So we've got the charge on the capacitor, which is varying. We've got the initial charge on the capacitor, which is some constant, and R and C are the resistance of the circuit and the capacitance of the capacitor, so these two are fixed. So the two things that are varying are the charge on the capacitor Q and the time T. And we're told that we're going to put time on the x-axis and on the y-axis the natural log of Q over Q naught. So first thing we're going to do is we're going to get Q over Q naught. So if we divide both sides by Q naught, we end up with Q over Q naught is e to the minus t over rc. Now I want to get rid of the exponential. Now logs are the inverse of exponentials. So if I take the log of both sides, I end up with log of Q over Q naught equals the log of the exponential of e to the log of the exponential minus t over rc. The log and the exponential cancel, so we end up with this being equal to minus t over rc. We're very nearly there. This is the thing that we're going to be plotting on the y-axis. This is the thing we're plotting on the x-axis, so I'm going to rearrange this slightly using the tricks we've already seen. I can add a 0 because I can always do that. Now, I can put this next to y equals mx plus c. I'm plotting log of q minus q naught on the y-axis. I'm plotting t on the x-axis. The gradient will be minus 1 over rc, and the intercept is 0. Again, with the last one, this is the capacitance of the circuit, and this is the intercept of the line y equals mx plus c, so don't be confused with that. So if we put our gradient in this box, that will be minus 1 over rc, and the intercept is 0.